Good morning. Today we are going to talk about nonlinear equilibrium model. As we said before, equilibrium is a situation with no tendency to change. So we can talk about equilibrium in case of linear functions and nonlinear functions. With respect to nonlinear, we are going to talk about quadratic and polynomial. Last time we talked about linear, now we are going to talk about the nonlinear ones. Let's start with an example for quadratic equation. As we said last time, that quadratic form or quadratic model has power 2 or square. The highest power is 2. So if you know that, QD equals 7 minus b squared and QS equals 4b minus 1. The required is to find equilibrium price and the quantity. Equilibrium will be achieved when QS equals QD. So 4b minus 1 equals 7b minus b squared. We can write it as 4b minus 1 minus 7 plus b squared equals 0. Then we can rewrite the equation as b squared plus 4b minus 8 equals 0. Now we can use the quadratic formula in order to solve the equation, where the quadratic formula states that negative b plus or minus square root 4b b squared minus 4ac divided by 2a. This is the answers for the quadratic equation. Okay, now we have to identify what is the value of a, b, and c. From the equation, we can write a as 1, as it's almost 1 b squared. Okay, b, which is 4, c is negative 8. Now we are going to substitute in the quadratic formula in order to find the value of b. So it is negative 4 plus or minus b squared, which is 4 squared, minus 4 multiplied by 1 multiplied by negative 8 divided by 2a. So as the power is 2, so we have to find two different answers for b. So b can be written as negative b plus square root b squared minus 4ac divided by 2a, or b equals negative b minus square root b squared minus 4ac divided by 2a. Okay, by substituting in the equation, it will be negative 4 plus square root 4 squared minus 4 multiplied by 1 multiplied by negative 8 divided by 2a, or negative 4 minus square root 4 squared minus 4 multiplied by 1 multiplied by negative 8 divided by 2a, which is 2 multiplied by 1. Okay, so the answer will be 1.464 or negative 5.46. Actually, this is the value for a price. Price couldn't be negative, so we are going to neglect this value. So this is the equilibrium price. Now we would like to find the equilibrium quantity. So we are going to substitute in QD or QS to find the equilibrium quantity. QD equals 7 minus b squared, which is 1.464 squared. So the answer will be 4.65, or you are going to substitute in QS. It will be 4 multiplied by 1.464 minus 1. So the value will be 4.85. So this is how to get equilibrium in case of quadratic model. What about the polynomial model? Polynomial model is any model whose power is greater than 2. So the highest power is greater than 2. 3, 4, anything. Okay, so this is a case of higher degree functions. Okay, say for example, you know that this is the polynomial one. If you know that QD equals 2b to the power 3 minus 2b squared, and you know that QS equals negative 18 plus 36b minus 2b to the power 3. So we have a power, the highest power is greater than 2, which is 3. So this is a polynomial case. Just like any equilibrium, equilibrium will be achieved when QD equals QS. QD is 2b to the power 3 minus 2b squared equals negative 18 plus 36b minus 2b to the power 3. So we can write it as 2b to the power 3 minus 2b squared plus 18 minus 36b plus 2b to the power 3 equals 0. Now we are going to sum them together. So it can be written as 4b to the power 3 minus 2p squared minus 36p plus 18 equals 0. Now we can use factorization in order to find the answer for this question. We can write it as two different brackets. Four b to the power 3 minus 2b squared plus negative 36b plus 18 equals 0. Now we can take a common factor from bracket number 1, which is 2b squared, 2b minus 1. And we can take a common factor from the second bracket, which is negative 18 multiplied by 2b minus 1. Now we can take 2b minus 1 as a common factor. So we can write it as 2b minus 1 multiplied by 2b squared minus 18 equals 0. Okay, 2b minus 1 multiplied by 2b squared minus 18 equals 0. Now using factorization, we are going to simplify this bracket. It will be 2b minus 1 multiplied by, we are going to take 2 as a common factor, 2b squared minus 9 equals 0. Now we can factorize this bracket as well to be 2b minus 1 multiplied by 2 multiplied by two different brackets, b minus 3, b plus 3 equals 0. Now we have three different brackets as the power is 3, so the answers should be three different answers. So we can write it as 2b minus 1 can be equal 0, or b minus 3 equals 0, or b plus 3 equals 0. So in the first case, 2b equals 1, so b equals half. So this is the first price, it can be half. With respect to the second answer, it will be b equal 3. So this is answer number 2. With respect to the third one, it's b equals negative 3. And as the price, this is a price for a commodity, it will never be negative, so we are going to neglect this one. So the price can be half or 3. So returning back to our equation, which states that QD equals 2b to the power 3 minus 2b squared, we can substitute in the equation using half and 3 in order to find the possible equilibrium quantities in each of the two cases. So in the first case, if price equals half, it will be 2 multiplied by half to the power 3 minus 2 multiplied by half to the power 2. So the equilibrium quantity in this case will be negative 0.25. So it is negative quantity, which is not acceptable, so we are going to neglect this answer. Now we are going to substitute if price equals 3. In this case, QZ will be 2 multiplied by 3 to the power 2 minus 2, to the power 3 multiplied by 2, minus 2 multiplied by 3 to the power 2. So the answer will be 36. So this is the equilibrium quantity. So from these three possible solutions, the first step we are going to neglect negative 3, and in the second step we are going to neglect the half as the quantity is negative. So the optimal answer is 3 and 36. What is the polynomial case? Polynomial case is just like drawing a graph like this one. This is the quantity and the price. This is supply and this is demand curve. In this case, we have three intersection points. This is number A, and this is number B, and this is number C. So we have three different answers for this model. All of them can be optimal, or just like in our example, we have to focus on only one of them and neglect the other ones. Okay, so this is equilibrium in case of polynomial and in case of quadratic. In the last examples, we talked about equilibrium in goods and services market. Now we are going to talk about equilibrium in national income analysis. Generally speaking, that equilibrium in national income model, or in another words, GDP using expenditure approach, is calculated as y equals c plus I plus g plus x minus m. If you are going to talk about equilibrium in national income model, we have to differentiate between two different situations, whether the economy is a closed economy or open economy. And in case of closed economy, we have to identify whether there is government in this economy or not. So let's start with the simplest form, which is a closed economy with no government. So in this case, there is no G, there is no X, and there is no M. As there is no, as this economy is a closed economy, so there is no export to import. And number two, as there is no government in this economy, so there is no government expenditure. So this model just includes consumption and investment. So now we would like to find equilibrium in case of closed economy with no government. As we said, equilibrium condition will be achieved when y equals c plus I. Consumption can be written as c equals a plus by, where a is autonomous consumption, which is the value of consumption if income equals 0. B is the slope, which is a change in consumption due to change in income by one unit. By is known as induced consumption, which is consumption which is affected by income level. So consumption is an endogenous factor, which means it's determined within this model. What about I? I is exogenous factor. Exogenous, which means it's not affected by factors mentioned in the model or given, determined by any other factors. So we can write I, which is exogenous, as I equals I node. I node or I bar means it's constant or given. So if we would like to find the equilibrium, we are going to substitute using consumption and investment in their equations. So we can write it as y equals a plus by plus I node. We can rewrite the equation by subtracting negative b from both sides. So it's y minus by equals a plus I node. This is autonomous consumption and this is autonomous as well, autonomous expenditure, investment expenditure. So we can sum them together to be a y minus by. Now we can take y as a common factor and we write it as negative b y equals a. Divide both sides by 1 minus b. So it is y equals 1 over 1 minus b a. So this is equilibrium level of income. Let's take an example. If you know that C equals 100 minus 0.7 y and the I equals 20. Required is to find the equilibrium level of income and consumption at equilibrium. So now we can substitute in this equation directly, where A equals small a plus I. Small a is 100 and the I is 20. So the total is 120. B equals 0.7. So now we can substitute in the equation in order to find equilibrium level of income. So y star equals 1 over 1 minus 0.7 multiplied by 120. It will be 400. If you are going to substitute in consumption, you can find consumption level at equilibrium. So it will be 380. Returning back to the first equation, which states that y equals c plus I. If you know that c is 380 and I is 20, so income in this case will be 400, just like this one. So this is in order to make sure that this is the correct answer. Okay, this is the case of close the economy with no government. If there is government, so we are going to add G and T. or in another words, government expenditure and taxes. And in this case, instead of Y, it will be YD, which is disposable income. Okay, this is your assignment for the next time. Just to find equilibrium using notation, not numbers. In, in case of closed economy with government and in case of open economy. Thank you and see you next time.